Hello everyone, Yurkun from the 430.com forums again here. So basically what I have here is a very simple project that I wanted to use to demonstrate what we have been working up to this point with the last two videos. This is a very simple project, and when I say simple, it is C++, so if you're not familiar with C++, it may be a little bit confusing, but I mean, you're probably going to recognize a lot of the code as, as what it really is basically just C. Minus, plus, of course, the fact of heavy usage of templates. It's very heavily templatized, but once you get past that, it's very straightforward code. So what I have here is I have a 22 line main file here. Okay, with your standard includes up here and followed by just a user-defined include here for my my file here, for my header file here. Using namespace UART, which is with the object that I'm going to be using from within my header file here. It's within this namespace. We have main here with a return type of int. Setting the watchdog into hold here so it doesn't trip us up, and keep on resetting our firmware here every 65,000 or so cycles. Clearing the DCO and then immediately setting it into 1 megahertz through the calibrated constants here, and then an SM clock divisor of 1, which gives us 1-to-1 SM clock to DCO, I suppose. Here I have an object called debug. I'm initializing it. Now debug is basically just an object that I'm outputting text out over UART or serial if you prefer. Here I have a variable called n, which is assigned the value of 1 through 8 of type int32. And then I'm outputting hello world with control line feed or return new line if you prefer, followed by the variable listed up here above. And then finally, within main here, I am returning 0 since we are of type int here. We need to return something. So a quick explanation of my my class file here, which is in form header, in the form of a header anyways. Namespace. Here I have the class definition here. Here I have my method for the initial for the UART object initialization here. You'll probably recognize a lot of this code from the Energia, some of the Energia code there, and that's because it's very slightly adapted to my own use. I think I renamed one variable here. And pretty much all of the rest of this, I believe, is Ricta59's code from Energia. Here, I have my my character write method, followed immediately by the string write method overload here. Pretty much just spits out, it iterates through the string one character at a time, and then calls the character write method for each character. Here I have the number conversion method that pretty much just converts numbers into type character for so you can actually spit out numbers over over the UART and whatnot here. This code also was all written specifically by Ricta59. Again, I've adapted it, and yeah, I've adapted it to my own purposes, which pretty much equates down to just me renaming a few variables, and then I had to change maybe 1 or 2 things to make it work with my own code here. But again, that's just that's Ricta59's code here. Okay, here I have a constant of type unsigned called base, which as you can see here equals 10. This number write method up here, it can actually spit out any base at least 1 through 16, and probably can go a lot higher than that. Haven't really examined this code that closely, but I'm sure it can at least go up to, let's see here, yeah, at least with the way that I have it set up here, at least up to 200 base 255. So if I want to spit out binary, I can set this to base 1 and it'd spit out binary. If I wanted to spit out hex, I just change the base value here to 16 and it would spit out hex. Here I have a type def of type UART, and then I have my baud rate here, followed by the M clock value here, which is 1 million or 1 megahertz. And if we take a quick look at this up here for the templates, you can see each template. I guess this would be a declaration here, would be of unsigned int32, and I'm taking in a baud value and an M clock value here. Basically, it's not used for most of this stuff here, but it is used for the initialize method up here when it's instantiated. And of course, that type def is called debug_t. Here I have a instantiation of my object debug of type debug_t. Here is an inline method, or the only generic inline method that I have for outputting my various different types. This could be misused to put out unexpected values if you really wanted to try to break it, I'm sure, but basically this is meant for the specific types of string and character. Down here we have specialized template, and this specific inline method here is for int32 type. Okay, here also, I don't remember exactly where I got this code from, but I think it's adapted from some of the Arduino stuff that I've seen here. I'm overloading the output operator here, so I can, when I write my code, like back in main.cpp here, I can just pretty much use standard C++ syntax, I guess you would call it here. And that's what that does anyways. So I'm overloading the operator to use it in such a way there. So anyways, I have int32, unsigned int32 going all the way down here to unsigned int8 types going there. So that's just a basic walkthrough of that code. So I guess enough of the talking, right? Let's get down to the pudding here. Let me go ahead and let's see where I want to be. I want to clean my project here. Now I want to build my project, and I need to raise this up a little bit. As we can see, as in a previous video, the output here is pretty much the same. We're running our source through G++, compiling down to an object file, taking that object file, running it through GCC as the linker, and then spitting the output out into an ELF file. Then we're lastly taking that out, that ELF file, and running it through MSP size as a post-build step. Now the reason why we're doing this is, or the reason why I'm doing this, you can do it for whatever reason you want, just to look at the pretty text or whatever, but the reason why I'm doing this is if you take a look at that ELF file on the file system, whatever you're using, you're going to see a file that's going to be about the size of 9 to 10 kilobytes. And obviously that's going to take up, you know, assuming that were the case, that's going to take up a good bit of the code space on the msp430. But luckily for us, that isn't the case. That's why we're using msp430 size here. We're using it to tell us what type of memory it's using for this given file here, which in reality is only 370 bytes. Which for what this program does, even though it's very simple and only spits out a single string and then a number value, is actually very tiny. It's about half the size of Opossum's printf implementation on the forums. Now, do keep in mind, we're also, or I am also doing a lot less with my implementation here than Opossum is doing in his. He has string formatting and all kinds of stuff built into his, and it's still, his implementation is still really tiny for what it does, but it's not quite as small as this. But although I'm doing a whole lot less. Anyways, enough babbling. If we come up to here to tools, user-defined tools, you'll see I have another user-defined tool here that I've made, and pretty much what this tool does, and I'm not going to go into too great a detail, I'll walk you through that in another video, is I'm just using MSP debug here, followed by some parameters and some macros from within Codeblocks here to point us to our ELF file. Then of course here for the working directory, this is our project output directory here, which is going to be, for this given case, since I'm running in debug mode, or I'm compiling in debug, this is going to be the debug subfolder under the project directory. Okay, so let's go ahead and run the program here. First actually, we go ahead and fire up PuTTY here. Yeah, I'm actually back on my COM5 device here for reasons I'm not going to get into here to keep from babbling. So anyways, running the tool here, we can see that it's gone through MSP debug. It's found our device and whatnot. It's telling us about our it's found two hardware breakpoints on our device, chip ID, which is the 2553, or the msp430 G2553 if you prefer. It's erasing the flash or the ROM on the device if you prefer, and then it's taking our ELF file and programming it, and then it's spitting out all this various output here, which is related, I guess, to our well, I'm not really exactly 100% sure what this is, but it's basically it's related to our output from msp430.size, I believe. And then down here it's saying done, 370 bytes total on the target. It's running pretty much, and then it's closing MSP debug. And then down here, the command line window through Codeblocks is telling us it's returned successfully. Okay, so if we come over here to our PuTTY window here, we can see that it's actually spit out what we've expected here. So there's the proof in the pudding for that given application. I think, you know, this is actually very useful depending on what you want to do and how you want to use it, or maybe it's not. I mean, it really depends on what you plan on doing with this specific code. For me, this is like a really simple, cheap way of doing text-based debugging within my code. So if something's not going as expected, I can just take a variable, I can spit it out over UART and see what's happening in the code to help me debug a project. Okay, again, something very simple. It's not going to replace actual disassembly debugging or anything like that, but it can be very useful for helping you determine what's actually going on in your code. So anyway, with all that out of the way, I guess you all take it easy, and I will catch you all in the next video.